So factorials can also be used when we consider arrangements. So if you have 5 books and they're arranged and you want to find out how many arrangements there are, you can use factorial. So if there's 5 books, it will be 5 factorial. So the number of arrangements of any n elements or objects is going to be n factorial. All right, let's have a look at some questions to do with that. So starting off with question 19 here, we want to find the number of different arrangements of 4 cards typed A, B, C, and D on them. For example, it could be A, B, C, D or B, C, D, A, so on. So you can see here, because there's only 4 cards, if I've used one here, there's not going to be any repeats, are there? So this is without repetition. So in this case, we consider there's 4 ways there's 4 places the cards can go. And in the first place, 4 cards can go there, yeah? But if I've already used the A card, that means there'll only be 3 cards left. Now I've already used the B and A card, which means there'll be 2 cards left. And in the last place, there'll only be D left, so that's 1. So that's how we get 4 times 3 times 2 times 1. And that's also the same as 4 factorial, which is 24 different arrangements. So can you see how that's why if there's 4 different elements, it'll be 4 factorial? Because we're actually using this method, but it follows in the factorial form, so it's much easier to just consider 4 factorial straight away and then type that in your calculator. So this is a good question just to show you why arrangements can be worked out by using your factorials. All right, let's move on to question 20 now. So here we're working with 9 people, and because it's people, if I place one person there, there's not going to be that person who's already used, so it's going to be without repeats as well. So 9 people are queued up in a line. How many ways can that be if any order is possible? So it doesn't matter where they are as long as they're in different places. So in this case, you can have them all lined up like this and so on. So there's various possibilities that it could be. And how we work that out is there's essentially 9 places and 9 people can go in the first one, but since person A is used, only 8 people can go in that one, and so on. So what you have actually is 9 times 8, so on, until 1, which is the same as just writing 9 factorial. So when we come across this question, we can just automatically think we're arranging 9 people without repetition. It's just 9 factorial. And you can just type that in your calculator. It says 9 and the factorial button is usually a shift to something. And press equal after that and you should get 362,880 different ways that 9 people can queue up in a line. That's quite a lot of ways when you think about it actually. Okay, well, with the questions that you're going to get, what happens is they try and change things up a little bit. So here we have one of these people really want to stand right at the start. So they insist on standing first. And that means that this person A, let's just say, is always going to be the first place. So if they're always going to be in the first place, can you see how this place essentially only ever has one possibility? There's only one person that can go here, yeah? So we're actually only working with different arrangements for the remaining 8 places. Exactly, it's going to be 8 factorial, yeah? Because that place can only be one option. So it'll be 8 factorial, which is just 40,320 ways, all right? So whenever you have someone who insists on being a certain place, you can essentially just remove that person, remove that place from what you're considering. Okay, let's have a look here. In this one person insists on being immediately behind another, okay? So let's just say B says I have to be behind A for whatever reason. So they can go anywhere, but B has to be behind A. And that means that what we're actually doing is we group them together. Yeah, so we consider them as one because they're always together. So in that way, we now actually only have 1, 2, 3, 4, this is grouped as another one, 5, 6, 7, 8 different places. Yeah, because those two people we group together. So because there's only 8 different places, it's going to be 8 factorial as your answer. And that was 40,320 ways. So when someone insists on being behind another person where the order is set, you just group them together. Similarly, if 2 people insist on standing together, what you need to do is group them together as well. But the only difference here is you can see you can have AB or BA because it doesn't say one person has to follow the other. So within that, there's actually arrangement of its own. So because they're grouped together, it's going to be, there's 8 different ways of arranging them. But AB can change their order. So there's actually 2 ways that AB can be in there. So it actually is 8 factorial times whatever the way is in here, which is 2 factorial. Now, we've only written 2 here because 2 factorial is the same as 2. But it's important you understand that it's 2 factorial. And that's because if you have, for example, 3 people insist on standing together, so let's just say we group these together. When you work this out, you consider them as one group. So there's only 1, 2, 3, 4, 5, 6, 7 places. Then you'll have 7 factorial, but you'll be multiplying it by the number of arrangements within that group, which is 3 factorial, okay? And that's why I want you to consider this as 8 factorial times 2 factorial, all right? And that's just going to be 80,640 ways. Yeah? And if you understand this concept, that means you can do the questions no matter how many people standing together. So even if you have 8 people standing together, if you use this same concept, yeah, then you can work it out for any of them, not when it's just 2 people. Okay, let's have a look at a different question now. So here we have 6 girls and 2 boys, and they're to be arranged in a row. So let's just say they're all lining up for sport or something like that. So how many ways can they be arranged in a row if there's no restriction? Well, it could be this, or any of these. Now, what's important to note here is, can you see how we have girl 1 and girl 2? So if here, girl 1 and girl 2 switch positions, it'll be a different arrangement. So you can't say that just because I'm a girl and I'm standing next to a girl and we switch positions, it's exactly the same because we're all girls. They're still people, and so if you change their positions, it's going to be different, yeah? So that's why we've written it as girl 1, girl 2, so on, and boy 1 and boy 2. So if there's no restrictions, then we just consider there's 8 different places. So in those 8 different places, at first we just do factorial, so it'll be 8 factorial, which will be 40,320 ways, yeah? So when working with girls and boys, or they'll make it so it's, people with red hair and people with brown hair or something, we just can still consider them as people. So you do consider them not as one group, but as individuals. Now, what if the 2 boys are together? So they insist on being next to each other. Well, in this case, remember what we did before? What do we do if they insist on being together? Exactly, that's right. We consider them as one group. So whenever people want to be together, we essentially group them together. Now, because it's one group, then it's a group of these 2 boys and 6 girls. So essentially, there's actually 7 different places now. Yeah, so there's 7 different arrangements. So it's 7 factorial. But remember, because you could be boy 1 and boy 2, or they could be flipped around as boy 2 and then boy 1, there's actually 2 different arrangements within this little group. So that's why we have to multiply it by 2 factorial. So it becomes 7 factorial times 2 factorial, but it's the same as 2, so that's why I've written it as that there. And that just equals 10,080 different arrangements. So remember, if people want to be together, just group them together, but don't forget about the arrangements within that group. Now, what if the 2 boys are not together? Now, this you think might be difficult because how are we going to think about if they're 2 places apart from each other, or 1 place apart from each other, or 4 places apart from each other. It will be too difficult if we did it that way. So the best way to do this is to think about all your different arrangements. So when there's no restrictions, minus when the 2 boys are together. So arrangements are when the 2 boys are together. So can you see how if you do that minus when the boys are together, whatever's left over is going to be the 2 boys not together? So that's what we're going to do. Remember, when there was no restrictions, that was just 8 factorial. When the boys were together, that was 7 factorial times 2 factorial. So considering that they're not together, you'll be 8 factorial minus that. So that just gives us 30,240 ways in which the boys are not together. So a lot of the times you'll see what happens if this does not do that, or is not together, or is not next to each other. Always consider all minus the arrangements that they are together or they are next to each other.